Hello everyone, thank you for coming. So I'm just going to start off today with a little test, alright? And so these are some heart rhythms. Can anyone tell me which one of these is the regular or normal heart rhythm? Alright, so in actuality, all of these are abnormal heart rhythms or arrhythmias. These are the names of all the arrhythmias among many other arrhythmias. This right here is the regular heart rhythm. So I didn't do this to make you guys feel stupid. I actually did this so that you guys could understand a little bit about what I've been learning this year and about my final product, which is an electrocardiogram. So an electrocardiogram measures the electrical activity of the heart. As many of you know and probably have seen on many television series and movies, you guys have probably seen this hooked up to a patient and, you know, that line that keeps on beeping. Yeah, that's an electrocardiogram. Or EKG for short. So, hello, I'm Amy Abraham, and I'm studying biomedical engineering this year in the Independent Study and Mentorship Program. So, biomedical engineering is the application of engineering principles and design concepts to medicine and biology for healthcare purposes. So, essentially, any device that you see in healthcare, whether it's an EKG, basically anything you see when you're in a hospital or in the doctor's office, those are all created by biomedical engineers. So as a biomedical engineer, you can go into 3 different paths and you can kind of conjoin to and do multiple of these things. You can either go into the industry side of it, which is basically working for a company, working directly with the product, fixing the product or creating the product in some sort of company, engineering company. Or you can go into the research aspect, usually professors with PhD usually do this. Go into researching, creating your own product, making new advancements, doing your own research, and hopefully getting it published. And then also there's the teaching aspect of it. You can also be a professor and teach biomedical engineering to college students or many other students. And yeah, so there's 3 different pathways you can take as a biomedical engineer, and they kind of intertwine. You can do all of them or just 2 of them. A lot of people that professors also have their own research, so it's all combined. You can do all of this throughout your lifetime. So it's very vast on what you can accomplish. So why bioengineering? That's a question I get all the time, like why bioengineering, mostly of all engineerings. And it takes me back to an experience I had in health science, clinical rotations, which is a class that I took last year in school, which basically allowed me to go to multiple hospitals and nursing homes and essentially just help out. And so it was one experience I had in the emergency room, and they got a call that someone that had flatlined was coming in. And so obviously as a teenager, I imagined that Grey's Anatomy scene where someone was getting rolled in on her gurney and there was one person on top of the gurney administering CPR, and it was hectic and everyone was yelling, move out of the way, and they went down the hallway, all of that, and there was so much conflict and chaos, and it was just crazy, and it was that dramatic scene everyone likes to see in movies and TV shows. Well, what I actually saw was far from that, and it's because of one device. And it was a device on the patient, and it's called the Lucas, and it's that's the company that makes it, but it's a chest compression system. Basically, that was administering the CPR on this patient, which is kind of amazing. And I kind of just watched in amazement how this one device made this whole scenario more efficient. It made everything more easy, moving the patient from the gurney to another gurney, hooking the patient up to the machines. It was just way more easy without another person on top administering probably horrible, not paced compressions. Instead, they left it up to a machine that was administering the correct amount of pressure, which was adjustable, and that did it in a perfect rhythm. So it was amazing to see how one device made this whole situation 10 times better, and honestly probably saved this person's life. So this leads me into my ISM journey, because I knew what I wanted to do, and it was biomedical engineering. So now I just had to learn as much as I could about it. And one of the ways we did that was research interviews. So I had to make multiple phone calls with multiple professionals that most of them who turned me down, but luckily I was able to get multiple interviews. These are five of the names of professors I interviewed from UTV and UT Southwestern, and they're the most memorable because all of them either taught me a little bit more about the field, about what they did, because many of them did their own research in biomedical engineering. They taught me so much and answered all my questions regarding college courses, anything essentially what I needed to know. They taught me about and taught me about their experiences as well. And it was great to learn from these professionals because they've already gone through the whole path. They've already gone through the whole college scenario and have learned so much and have started their own research. And hearing about their research was especially amazing because they've done amazing things, and honestly now they're just teaching other students, which is great. But out of these interviews, one was the most outstanding and one I really enjoyed, and it was with my mentor, Dr. Joe Pacheco. So Dr. Joe Pacheco is a senior lecturer at the University of Texas at Dallas, and he teaches senior design. And he is an amazing mentor. He had essentially, through this mentorship, I was able to meet with him every single week, and he was so gracious enough to meet with me for an hour every week, and we just sat down, talked about engineering concepts, computer science, a lot of coding that I learned. We basically just went through what I needed to reach my goal of my final product, and it was great. He spent so much time with me, and I'm so thankful. And so yeah. And so one of the experiences I was able to gain because of him was UTD Senior Design's Expo, which is basically his students who also picked their own products and made advancements to products. They basically got to describe their products and explain how they were going to make their products, which was very interesting to hear. So two of the projects are up there, and one was to clean a cleaning tool for the G-tube, and another was to help a person with a limp swing their leg. It was a strap for them to swing their leg and help them initiate the walking. And so it was really cool to see how little advancements could help so much, mostly with the efficiency, the cost efficiency, mostly for the G-tube, because they wanted essentially a cleaning utensil that avoided infections so that you didn't have to replace the G-tube so frequently, which would require multiple surgeries, multiple very expensive surgeries. And so little things like that made it more cost effective, made that person's life, that patient's life, a lot more efficient. So to move on, the next step of my ISM journey was Business Symposium. Business Symposium was great, and it essentially made all of us ISM students go to Independence High School, and we sat down and talked to random professionals, not of any field in particular, and we basically had to go up, introduce ourselves, start conversations about random things. It really helped with my social skills first and foremost, even more than the interviews that we did, because it was completely finding anything to talk about. And so it was interesting talking to people of different fields, asking them about their experiences, and it was just an amazing way to build upon my social skills as well. Because I started off this year not so strong. Talking to professionals and talking to teachers, I was really quiet, and that's something everyone knows about me, but now I've become more open through events like Business Symposium that allowed me to get out of my comfort zone and get less nervous about things like this. So it was a great event. I saw many of my friends from other schools, so it was awesome to see everyone, to interact, to have that social event. And to actually build connections through it too. And then another event that we had was Research Showcase. So Research Showcase this year was held in the Star Stadium in Frisco. And essentially all of us ISM students had our boards set up, and we had to present all that we had done so far, and mostly it was our original work, and what we've learned about our field so far through our research interviews, through our assessments, all of that. And so it was on display at the Star Stadium, and so basically it was open to anyone, and anyone could come by and ask us about what we've learned so far. And this was another great experience because I talked to many parents and kids that wanted to be biomedical engineers, and that asked me questions, and it was great to see everyone's questions, to answer as much as I could, and I actually help a lot of the little kids out as well. So it was great to have that social interaction with all of them, to be helpful and to learn a lot, because I've learned a lot from many professionals that walked by that knew more about the field than I did. So it was great to be part of that and to learn so much more, and also work on my social skills and get more out of that comfort zone I'm usually in, and to make more social interactions. And then that kind of leads me into my research, because before I decided on the electrocardiogram, I had to narrow it down to that device. And so I looked into many devices like the pacemaker, the ECG, and the bionic heart. So the pacemaker, as many of you probably know, is installed in patients with abnormal heart rhythms, and so which basically shocks their heart into the right rhythm. And so that was one of the devices I was thinking of making and thinking of researching, which would have been awesome, but I decided against it. And so I also looked into the ECG, which is basically measuring the electrical activity of the brain, very similar to the EKG, so I actually looked into it a lot. And that's the picture of it right there. And then I also looked into the bionic heart, which is a fake heart, and this is not that well of a developed machine, and it was still experimental. So I didn't know whether or not I really wanted to do it, but it was awesome to research it, see how it incorporated the valves of the heart, and how it was used. But then eventually I determined that I wanted to create an electrocardiogram. And so my original work, because I knew what my final product what I wanted it to be in the beginning, early on, I was able to direct my original work toward my final product. So my original work was an instructional manual to help me build the EKG. And you're probably wondering why I did that. Well, it's because my mentor is smart enough to probably make an EKG in about an hour at tops, right? But I needed that background knowledge, so I probably didn't look that stupid compared to him. And so I had to do my background, do my research, and so I thought the best way to do this is basically create an instruction manual, gather as much info as I can off online sources and off other sources, and basically create the manual that I'd use to create my EKG. And of course, it was flawed. It was some parts were completely wrong, some parts were very useful. But I tweaked it and made my actual original, basically a final draft of my original work as I created my final product, which was actually really cool, because now I have my final product, and then I also have an instructional manual if any of you guys want to make my final product. I don't know if you guys would, though. But yeah, and so these are a few pages of my original work. I also have it here with me, the rough draft and the final draft, and so you guys are welcome to look at that. But these are some pages, the table of contents, which basically just describes all the parts. I'm going to do probably a brief explanation of everything right now. However, that goes more in depth about all of the parts, all of what to connect, how to connect it, all the coding, all of that is in there. And so please look at that after this if you'd like. So the first thing I learned on my mentor visits was about circuits. And this was a throwback to Physics 2. And so I had to learn, we sat down, me and my mentor, and we learned a lot about different things like resistors, capacitors, all types of wires, and everything that you could possibly learn about circuits, operational amplifiers, and measuring the voltages and currents and all sorts of stuff like that. And we basically just had an overview of that, and I also learned about a breadboard as well, which is basically part of your own circuit that basically you can connect wires to make more complex circuits, basically. And it was great to actually work with that as well, and so I was able to use this to create I needed to know more about circuits to create my EKG, because it was basically a circuit used with a little bit of coding to make that. And so the first thing I needed in my circuit was the Arduino 101. So the Arduino is an open source electronic prototyping platform used to create electronic objects. It has a Bluetooth feature, and it's basically where most of my code went. So I started experimenting with the Arduino, first of all. Easy things. Right here I have a picture of the Arduino, and then it has a small circuit with a resistor and LED. and essentially I had to make the light bulb blink. And so I wrote this right here is my very first code, and so I was actually very excited about that. And I was able to light up the light bulb. And not only was I able to light up the light bulb, but I learned a little bit about code and how efficient it is. I was able to control how often this light came off, or how it dimmed or got bright, or if it just came on like quick flashes, how quickly it did that. It was kind of amazing how just one tweak of the code could change the circuit, change how this light bulb lit up. And so then I continued experimenting with Arduino, saw different things I could do, made the Arduino produce words and output and input stuff, which was very cool. The next program I used was processing. And processing is a program that allows a person to sketch or create some visual art using code. So essentially the processing would be where I outputted my wave, where you could see the visual art of my wave, and you could see the PQRST wave of the heart. And so I started with basic functions such as the rectangle function, rect for rectangle, and basically put in the dimensions for a rectangle and created a rectangle. And then I moved on to color, the RGB function, and the amount of red, blue, and green inside the color, and it basically made all the colors in the color wheel. And then I got more and more advanced, creating lines, trying to make certain shapes, and so I basically just had to experiment and work with processing and get a feel for it. So that was another one of the programs I used. And then the last device I used was the 88232, which is the heart rate monitor. And this basically hooked up to the cords. So this is an integrated signal conditioning block for EKG and other biopotential measurement applications. And so essentially these also had most of the operational amplifiers which basically extract, filter that signal and amplify that signal to an output. And so this little chip was basically connected to the person through wires. And if you see my final product, you can see how it all is intertwined. And so essentially I was going to use these three devices in order to make my EKG. So these are the three things I used in my circuit, and they worked with each other. The leads connect to the 88232, the heart rate monitor, which then sends the signal to the Arduino. The Arduino takes it in and then sends it to processing, and then processing displays it on a screen, which is awesome. How it's all incorporated, how one program sends info to another. And it was very cool, and I had to experiment a lot, and my code is different because I had to do things like put an average moving filter on the Arduino code because the line was picking up too much noise and there's too much frequency in my heart wave. And so I had to put a moving average filter, which made the line of the EKG smaller. So little things like that I had to incorporate into my code. I had to learn a lot about different functions and loops and for loops. For loops. That was interesting as well. And so what I learned most was problems always arise and not to worry. Because one thing I struggled with a lot through this mentorship with all my meetings was programming. I'd had very little computer science background, a very little coding background, and so this is one of the things I struggled with, and I tried learning even outside of my mentorship with the help of some friends. And so coding both in processing and Arduino was difficult, but I kind of had to get the hang of it, writing the code, and I learned a lot about debugging, which is going back and fixing the code. And the thing about these programs, they don't tell you exactly where the error is, so you have to go back and fix your error. So it's a tedious process, but I learned so much in the process about computer science, which I'm going to have to take classes on in college. So it was all very beneficial to learn about this, as well as how it incorporates into my product. All of that was very beneficial. And the amount of coding knowledge I got was probably the biggest benefit I got from this mentorship, because I know I'm going to do that in the future, a lot of coding, and so it was very helpful to learn this and to see how it works. So with that, I'm going to conclude with my quote. My quote is, "So you can waste your life drawing lines, or you can live your life crossing them. Here's what I know. If you're willing to take a chance, the view from the other side is spectacular. This quote is from Shonda Rhimes. It's really just an inspirational quote about how you should always cross boundaries. You should always go beyond what is expected. And I did go beyond what I thought I was capable of achieving this year in so many ways. I did not think I'd learn so much, mostly about coding. I didn't think I'd be able to actually create an EKG. I didn't think I would be as involved, but I was very focused. I put a lot of work into it, and I'm very proud of what I've created. I went beyond my limit, I crossed all the boundaries I could. And looking back on it, I'm so glad I had this experience. I had the experiences I had with professionals, talking to people, creating better social skills, all of that. And I'm so blessed to have all the interactions I've had, and to be able to sit down with an amazing professor, learn so much, and create my product. And so that leads me to my thank you. I want to thank everyone that's here right now. I want to thank especially my mentor, who's taught me so many things this year, way more than any of my other classes taught me, for sure. Thank you to my mentor for sitting down, taking the time out of his day, waking up early because our meetings were in the morning, and sitting down and teaching me fundamental engineering concepts as well as computing, and mostly teaching it to me, who asked him to repeat stuff 3 or 4 times. So thank you so much for putting up with me and teaching me so much. I also want to thank my sisters and my parents for supporting me and helping me buy all of the equipment I needed, as well as helping me with my speeches and helping me prepare my board and all of that, as well as my volunteers and all my friends that helped me with my board. I also want to thank y'all. I want to thank Raheel. He's not even in this room right now, but he helped me with coding as well when I was completely lost. So he also helped me. He's in his room doing his presentation. And I want to thank all my volunteers that helped me set up today, especially, and all the other events that we've had in ISM. If you helped me, thank you so much. I really appreciate all that you've done. Thank you all for being here today. Thank you, and have a nice day.